My name is Farsh, and today we'll be doing the chemical energy conversions experiment. This experiment is designed to explore chemical energy and how it can be converted to other different forms of energy. Start by asking students to list different forms of energy. As they give their answers, make sure to write what they say on the board, slowly filling in this diagram without the arrows. A common answer that may come up is potential or kinetic energy. These are just states of energy and not actually forms of energy. If students mention sound energy and mechanical energy separately, be sure to emphasize that sound energy is just a form of mechanical energy, as sound energy is just pressure waves through the air, which is a form of mechanical energy. Tell the students that this experiment will focus on chemical energy and its conversions to other energy forms. As you say this, have another VSVS member draw arrows between chemical energy, thermal energy, light energy, and mechanical energy. Put sound energy in parentheses as it is a form of mechanical energy, as explained before. Be sure to make these arrows double-sided, as we'll be exploring the conversions of energy from chemical to these other forms and then back. Next, explain that chemical energy is the energy that is stored in bonds between molecules. Because of this, and because of the energy is stored, it is considered a type of potential energy. Ask the students what they think that this type of potential energy could be used for. Be sure, some examples include eating food to move and to breathe and to think. Another example is using wood to create heat and light. Next, ask the students what they think happens to the energy after we use it. In this discussion, be sure to emphasize that energy is neither created nor destroyed, the conservation of energy. Another point to emphasize is the fact that energy in the universe always remains the same. It is merely converted from one form to another and vice versa. Moving on to the first activity. So this activity, explain to the students that it will convert chemical energy to 4 different forms of energy, or 3 to be technical, because we're saying that sound energy is almost the same as mechanical energy. So, the materials you'll need are a coffee can, the lycopodium powder, pipette, a tea candle, and of course goggles. Make sure all the students have goggles before they do this experiment, even though it's just a demonstration that you'll be doing at the front. Prior to doing this demonstration, ensure that the students are divided into groups of 3 or 4, and that each student has an observation sheet. All right, let's begin. So, first thing to do is put on the goggles. Cool. Then you want to put the candle in the coffee can before you light it, otherwise it'll be hard to put it in while it's lit. Make sure the coffee can, or the candle is in the center of the coffee can. Next, you'd want to fill up the pipette about this far with lycopodium powder. The more you fill, the bigger the explosion will be, and it might be cool, but it might be also unsafe. So keep it to the tip of the pipette. Once you have the lycopodium powder, insert the pipette through a hole in the side of the coffee can. And angle it towards the tea candle. The next step should be done really fast, otherwise the candle will go out from a lack of oxygen. So you want to put the lid on top, close it, and squeeze the pipette head as hard as you can so that the powder in the pipette will become aerosolized almost, and it will catch fire from the tea candle. So, as you can see there, it doesn't always work. And the appropriate way to approach this is just to reset, relight the tea candle if necessary, take more lycopodium powder, and do it again. So once again, insert into the coffee can and angle the tip of the pipette towards the tea candle, and then close the top and squeeze the pipette head as hard as possible. There should be a big explosion, something like that. The lid may fly off and there will be smoke coming out of it. in addition to like a flash of fire. Tell the students that at the end of this lesson we'll repeat this experiment and they will be able to name all the energy conversions that just took place. For the next activity, give each group a light stick. This should look like this. For the demonstration, take the larger light stick. Explain to the students that inside each of these light sticks there are two sets of chemicals, one of them inside of a glass vial and one of them surrounding the glass vial, but just inside the plastic tubing. When we break the light stick, the chemicals interact and produce light. Tell the students to do the same. Once all the students have broken their light sticks, ask them what type of energy conversion they think took place. The answer should be chemical energy from the bonds in the two chemicals to the light energy emitted from the light stick. The students can now answer question 1 on their observation sheet. In the next activity, students will be using chemical hand warmers. Give each group one hand warmer. Have one student take the metal disc by 4 fingers and try to bend it in half. What happens next is that the liquid should precipitate out into a white solid and heat should be generated. This is because the solution inside of here is actually a supersaturated solution, which when disturbed by bending the metal coin will cause the solid to precipitate out, a reaction which is exothermic. Collect the hand warmers and put them in the bucket. Then ask the students what type of energy conversion just took place. The answer would be chemical to thermal energy. Then go on to explain that this process can be reversed by boiling the hand warmers in water for a period of time. This shows that the thermal energy from the boiling water can be used to convert the heat that was released from the hand warmer back into the chemical bonds into chemical energy. This illustrates the important concept of the conservation of energy. Then go on to explain a couple of applications for the conservation of energy. For example, when you sweat, the liquid droplets on your skin absorb the heat from your body, the thermal energy, and convert that to chemical energy, becoming a gas. This cools you off in the summer. For the next activity, explain to the students that we will be using a form of energy and converting it to chemical energy, rather than in the previous activities where we converted chemical energy to other forms of energy. So for this experiment, for this part of the experiment, you'll need a jar of potassium chloride for each group, plastic spoon, 50 milliliters of water measured out in the graduated cylinder. During the experiment, the students will actually pour and measure for themselves to practice measuring skills, but for the purposes of this video, I've measured it already. A styrofoam cup where the reaction will take place, and a plastic plate to catch any water that might spill. Explain to the students that the thermal energy in the water will donate some of its energy to dissolve the potassium chloride once we stir it into the water. This will make the water temperature drop significantly, about 10 to 14 degrees Celsius. First, we'll look at the thermometer. Make sure that the students know how to read the thermometer. Tell them that the red liquid will rise according to the temperature, and that where the top of the red liquid lies, that's the temperature to read. Make sure that they're reading on the left side of the scale, as that is the degrees Celsius side. So, to begin this experiment, pour the 15 milliliters of water into the styrofoam cup. And add 2 spoonfuls of potassium chloride. Then, stir for about 2 minutes. Make sure the students record the temperature of the air by holding the thermometer in the air, and then also the temperature of the water before they begin mixing. This way they'll be able to see the difference in temperature once the mixing and the dissolving has been completed. After about a minute of stirring, the students should notice that the water gets colder. By looking at the thermometer, the temperature of this water has dropped to nearly freezing, 0 degrees Celsius. If the students cannot feel the water getting colder, instruct them to take the thermometer out of the cup and feel the bottom of the thermometer. It should be cold to the touch. Explain to them that a cold pack works in a similar way. There should be one in the kit. Activate it and pass it around to have the students feel how cold the cold pack can get. Explain that in the cold pack, Two sets of chemicals, ammonium nitrate and water, are separated by a thin barrier. When you activate the cold pack, that barrier is broken, the chemicals mix, and in the dissolving process, heat is absorbed, making the cold pack feel cold. This is a very similar process to what we just did. By dissolving the potassium chloride in the water, the heat from the water was extracted and used to dissolve the potassium chloride. This makes the water cold to the touch. We'll end this experiment with a bang. So we're going back to the first activity, doing the exploding coffee can experiment. But this time we'll ask the students to name all of the energy conversions taking place. So once again, be sure to do safety first, wear your goggles, then light the tea candle inside. Get an appropriate amount of lycopodium powder into your pipette. Remember to fill it only to the tip. We don't want too big of an explosion. Then insert the pipette into the coffee can through the small hole and aim it at the tea candle. Remember to close the lid and squeeze the pipette head in quick succession, otherwise the candle will go out. And once again, it may not work on the first try. So just refill your pipette with lycopodium powder, light the candle if necessary, and do it again. Ask the students what types of chemical energy conversions just took place. There are about 3 or 4 different answers, depending on whether you count sound energy the same as mechanical energy or not. So first, we saw a mini fireball. That is a form of both thermal energy and light energy. It gave off heat, and we also saw it. Mechanical energy actually was produced in 2 different forms. First, the gases built up in the coffee can and popped the lid off far away. In addition, we heard the sound of the lid popping off, which is another form of mechanical energy, or sound energy. Once you finish the lesson, be sure to clean up and collect all the materials. Dump all the water from the potassium chloride part of the experiment down the drain or collect in the water bottle provided. Be sure to review the questions and the major vocab from this activity, and have a great lesson.